Torsion in shafts, tutorial questions number 5. This one is quite an algebraic one too, but again we extract the information we know. We're given the power, so we get that into a convenient unit. We're given that it's rotating 120 revolutions per minute. That's a bit of a typo there, it should be per minute. So that turns out to be a frequency of 2 Hertz dividing by 60, and then tau again in convenient units. But we're also told that 3 times the inner diameter equals the outer diameter, because they're in the ratios of 1 to 3. So in other words, 1 outer diameter is equal to 3 inner diameters, which is how this is how it will be written algebraically. So now it's a case of trying to work out what these are. So I've gone through the steps over leaf. Let's see if we can go through it. So first of all, from the torsion equation, these are the ratios we're interested in. T over J equals tau over R. We're after R effectively. So we flip it over to get J over T equals R over tau. But R is half the diameter, the outer diameter. But the outer diameter is 3 times the inner diameter. So we can write that the radius is 3d over 2. So putting that into here, we get that J over T equals 3d over 2 tau. Then we get J equals 3d over 2 tau times T. And I've done that because we don't know J, but we do know a formula to find J, and that's this. Pi d to the 4 minus d to the 4 over 32. But remember, d to the 4, d can be written as 3 times the inner diameter. So with a little bit of playing around, timesing both sides by 32 and dividing by pi, we get this line. D to the 4 minus d to the 4 is 48 e2 over pi tau. Have a look, see if you can see those steps. Then remember, capital D is 3d, so we can substitute that in instead. 3 to the power 4 is 81, so that's 81 d to the 4 minus d to the 4 equals the right-hand side. 81 d to the 4 minus d to the 4 is 80 d to the 4. So then we can divide by 80, tidy up, 48 over 80 is 0.6, so we get d cubed equals 0.6 t over pi tau. But we know that t is the power over omega, the angular velocity, so we can put power over omega in instead of t to get this line. So d is the cube root of all this. But of course omega, angular velocity, is 2 pi times the frequency. We know the frequency, so instead of omega we can write 2 pi f here, that's this bit. And then tidying up, because pi times pi is pi squared, and 0.6 divided by 2 is 0.3, we end up with this line. And then putting in the numbers, we get an inner diameter of 0.091, so therefore the outer diameter must be 3 times that. So d equals 0.273